Ok, bây giờ em giới thiệu cái phần mềm indusoft webstudio truyền thông Modbus TCP IP Ethernet với Arduino Mega 2560. Giờ chúng ta mở cái phần mềm indusoft này. Tín hiệu analog sẽ được thu thập về cái này. Analog thu thập về máy tính thông qua Modbus TCP IP. Đấy nha, chúng ta sẽ on off ở thiết bị thông qua Modbus ở trên chỗ Arduino này. On off on. Đấy, còn đây các dữ liệu tín hiệu analog sẽ được thu thập thông qua các cái biến trở này đi về Arduino Mega và truyền thông Modbus TCP IP để lên phần mềm indusoft. Ở đây chúng ta cần lập trình cái đèn ở đây nè. Bây giờ chúng ta sẽ kết thúc video để chúng ta hướng dẫn cách làm. Bây giờ mình chỉ sửa cái project chút xíu, sử dụng cái phần mềm copy này ra ngoài screen. Paste. Ta sẽ cắm nguồn sạc.
Làm gì á? on the same pair of wires.
Xin chào các bạn, nay mình sẽ trước đây mình đã làm cái video về Modbus TCP IP Arduino với WinDC hoặc Kepware rồi. Bây giờ tôi sẽ làm cái Modbus TCP IP indusoft webstudio, cái phần mềm này của Schnieder. Cái nguyên liệu có thì mình trước đây mình đã nói sơ sơ rồi. Nguyên liệu của nó đây ha. Trong cái bài trước mình đã làm rồi. Thì chúng ta sẽ lướt qua cái phần mềm. Đây là cái phần chương trình để nạp cho con Arduino Mega 2560. Cái phần chương trình của nó thì mình không nói thêm nữa. Các bạn có thể xem trong cái video của mình ở trong này. Đây là cái video liên quan đến cái chương trình, cách viết này, nó trong này có hết rồi. Bây giờ mình chỉ có hướng dẫn cho các bạn đọc chương trình Modbus TCP IP lên indusoft webstudio. Trước tiên thì ta kiểm tra chương trình có hoạt động hay không. Ta dùng cái phần mềm mô phỏng cái Modbus để kiểm tra cái tín hiệu Modbus phones. Rồi bây giờ chúng ta sẽ kết nối với server của nó. Địa chỉ IP là 192.168.10.10 và port 502. Chúng ta thấy được rằng cái tín hiệu analog đầu vào của nó đang đọc rất là tốt này. Không có bị lỗi. Đồng thời chúng ta sẽ lướt qua cái chương trình Arduino. Đây là chương trình của Arduino thì địa chỉ IP address của nó này, gateway và subnet. Chân số 2223222426 là cái ngõ ra digital output. Và cái Modbus chúng ta là holding register, ta đọc các thanh ghi. Bây giờ nhiệm vụ chúng ta là sẽ thực hiện dùng indusoft webstudio để mà đọc dữ liệu và truyền dữ liệu ra Arduino. Trước tiên mình giới thiệu về phần indusoft. Indusoft webstudio là phần mềm rất hay. Nó là một phần mềm SCADA của webstudio của Schnieder. Ứng dụng của nó có thể làm các cái ngôi nhà thông minh, giám sát, các thiết bị trong nhà chúng ta sẽ được điều khiển thông qua truyền thông Modbus TCP IP. Ở đây Modbus TCP IP có thể dùng nhiều cái dạng truyền thông là truyền thông Wi-Fi hoặc là truyền thông Ethernet có dây. Khi mà chúng ta thực hiện được kết nối được với phần mềm indusoft webstudio thì chúng ta có thể cấu hình đàn web server để sử dụng nó để điều khiển thiết bị qua internet hoặc qua các cái thiết bị di động. Rồi.
By using a handheld programming and configuration device, often called a HART communicator,
bây giờ chúng ta
this data can be accessed wherever the opportunity exists to connect the handheld device in parallel to the loop wires. This can be in a junction box, marshalling panel, or at the sensor itself. So if a sensor is in an inaccessible or hazardous area, configuration or maintenance of the sensor can be done from a safe, remote location. Networking HART devices in most control systems applications is not practiced. Because of its limited speed and its cumbersome multi-drop network topology, we generally assign only one node or sensor to each HART signal loop. Fortunately, HART allows for multiple master nodes, so that the control system and a handheld communicator can both be connected to the loop and can communicate with the device at the same time. With HART, the analog 4 to 20 milliamp signal and the digital HART protocol are both available to the control system and instrument technician. If a sensor loop is upgraded from analog only to analog plus HART, the control system programming and configuration for the measurement value can stay the same. You can imagine that superimposing an AC signal on top of a DC signal might interfere with the 4 to 20 milliamp signal, but this is not the case. The AC HART sine wave oscillates at either 1200 Hz for a 1 value or at 2200 Hz for a 0 value. the amplitude of the AC sine wave remains the same, and for every oscillation, the amplitude of the first half of each sine wave above the DC current curve exactly equals the amplitude of the second half of each sine wave below the DC current. The net effect of the sine wave is then 0. So, the analog value of the sensor measurement data is not affected by the heart signal, just as a telephone voice conversation is not affected by the caller ID signal using the same Bell 202 protocol. Each heart device is capable of sending and receiving 35 to 50 different information items, including the process variable, that is the same measurement value as provided by the 4 to 20 milliamp analog signal, device status, diagnostic alerts, like sensor value under range, basic configuration parameters, like upper and lower range limits, and the tag name of the device. HART is a perfect choice for multivariable instruments, like mass flow meters, where mass flow, volumetric flow, temperature, and density can all be communicated to the control system over a single cable. The HART protocol is governed by a vendor-independent association, the HART Communication Foundation, so HART sensors from any manufacturer can be interchanged with those of other manufacturers. This makes implementation, maintenance, and troubleshooting very easy. Also, HART is used extensively for final control devices, such as control valve positioners, with the same benefits and diagnostic capabilities. Even though the HART standard requires manufacturers to provide a minimum number of specific data items with every HART sensor, vendors can also extend the data set to include vendor-specific items, like sensor model numbers, or firmware versions or advanced diagnostic counters. In order for the control system to recognize the type and values for these custom data, a special description file called a data description or DD file is required. This file is loaded on the DCS or PLC configuration station or downloaded to the handheld communicator and becomes directly associated to the sensor. This file simply allows the data stream from the sensor to be correctly parsed or interpreted and allow the technician or engineer to make the correct requests for sensor data. To review, HART is a digital data communication protocol that is layered on top of a traditional analog 4 to 20 milliamp signal, which provides advanced data retrieval and configuration options to be executed remotely from a DCS or PLC system, or from a handheld communicator. HART communicates over a single pair of wires, so adding HART to an existing 4 to 20 milliamp sensor loop requires no wiring modification. Only the hardware at the analog input card and the sensor electronics may need to be upgraded so that the HART functionality is provided. A high percentage of sensors already installed in 4 to 20 milliamp loops are already HART enabled. HART may be the field bus you already have in your plant. Through simple configuration, a wealth of new process data and diagnostic capability can be obtained with a minimum of effort and expense. Make sure that you head over to realpars.com to find even more training material for all of your PLC programming needs. We offer many videos to assist you in learning PLC programming and landing that job in the high-paying, highly sought-after field of automation and controls engineering. Go to realpars.com and subscribe to our highly effective training series now.
0, 1, 2, 3, 4 đây.
Have you ever thought about how a robotic vehicle commonly used in military applications with bomb detonation is controlled? Or how metal cutting and forming machines provide precise motion for milling, lathes, and bending for metal fabrication? Or how an antenna positioning system controls the precision in azimuth and elevation? As you'll learn in this lesson, servo motor applications are most commonly used in closed-loop systems, where precise position control is commonly found in industrial and commercial applications. Together with the recently published RealPARS video, What is a Stepper Motor and How It Works, and this lesson, you'll learn about motion control using different types of motors available, primarily stepper and servo motors.
T11. Okay. Trong đó chúng ta sẽ vào hai cái nút nhấn Graphics Buttons.
Before we get into today's video, if you love our videos, be sure to click the like button below, and make sure to click subscribe and the bell to receive notifications of new RealPARS videos. This way, you never miss another one. In this lesson, we will discuss what a servo motor is and how it works. So let's first determine what a servo motor is and examine some unique features of the types of a servo motor and its application. Servo Motor Basics. Let's begin with the servo motor basics. Servo motors are part of a closed-loop system and are comprised of several parts, namely a control circuit, servo motor, shaft, amplifier, and either an encoder or resolver. A servo motor is a self-contained electrical device that rotates parts of a machine with high efficiency and with great precision. The output shaft of this motor can be moved to a particular angle, position, and velocity that a regular motor does not have. The servo motor utilizes a regular motor and couples it with a sensor for positional feedback. The controller is the most important part of the servo motor, designed and used specifically for this purpose. The servo motor is a closed-loop mechanism that incorporates positional feedback in order to control the rotational or linear speed and position. The motor is controlled with an electric signal, either analog or digital, which determines the amount of movement, which represents the final command position for the shaft. A type of encoder serves as a sensor, providing speed and position feedback. This circuitry is built right inside the motor housing, which usually is fitted with a gear system. Types of servo motors are classified into different types based on their application, such as the AC servo motor and DC servo motor. There are three main considerations to evaluate servo motors. First, based on their current type, AC or DC, and secondly, on the type of commutation used, whether the motor uses brushes, and the third type of consideration is the motor's rotating field, the rotor, whether the rotation is synchronous or asynchronous. Let's discuss the first servo consideration. AC or DC consideration is the most basic classification of a motor based on the type of current it will use. Looking at it from a performance standpoint, the primary difference between AC and DC motors is in the inherent ability to control speed. With a DC motor, the speed is directly proportional to the supply voltage with a constant load. And in an AC motor, speed is determined by the frequency of the applied voltage and the number of magnetic poles. While both AC and DC motors are used in servo systems, AC motors will withstand higher current and are more commonly used in servo applications such as with robots, inline manufacturing, and other industrial applications where high repetitions and high precision are required. Brushed or brushless is the next step. A DC servo motor is commutated mechanically with brushes using a commutator, or electronically without brushes. Brushed motors are generally less expensive and simpler to operate, while brushless designs are more reliable, have higher efficiency, and are less noisy. A commutator is a rotary electrical switch that periodically reverses the current direction between the rotor and the drive circuit. It consists of a cylinder composed of multiple metal contact segments on the rotor. Two or more electrical contacts, called brushes, made of a soft conductive material, such as carbon, press against the commutator, making a sliding contact with segments of the commutator as it rotates. While the majority of motors used in servo systems are AC brushless designs, brushed permanent magnet DC motors are sometimes employed as servo motors for their simplicity and low cost. The most common type of brushed DC motor used in servo applications is the permanent magnet DC motor. Brushless DC motors replace the physical brushes and commutator with an electronic means of achieving commutation, typically through the use of Hall effect sensors or an encoder. AC motors are generally brushless, although there are some designs, such as the universal motor, which can run on either AC or DC power, that do have brushes and are mechanically commutated. And the final classification to consider is whether the servo motor application will use a synchronous or asynchronous rotating field. While DC motors are generally categorized as brushed or brushless, AC motors are more often differentiated by the speed of their rotating synchronous or asynchronous field. If we recall from the AC-DC consideration that in an AC motor, speed is determined by the frequency of the supply voltage and the number of magnetic poles. This speed is referred to as the synchronous speed. Therefore, in a synchronous motor, the rotor rotates at the same speed as the stator's rotating magnetic field. However, in an asynchronous motor, normally referred to as an induction motor, the rotor rotates at a speed slower than the stator's rotating magnetic field. However, the speed of an asynchronous motor can be varied utilizing several control methods, such as changing the number of poles and changing the frequency, just to name a couple. The working principles of a DC servo motor are the construction of four major components: a DC motor, a position sensing device, a gear assembly, and control circuit. The desired speed of the DC motor is based on the voltage applied. In order to control the motor speed, a potentiometer produces a voltage which is applied as one of the inputs to error amplifier. In some circuits, a control pulse is used to produce DC reference voltage corresponding to desired position or speed of the motor, and it is applied to a pulse width voltage converter. The length of the pulse decides the voltage applied at the error amplifier as a desired voltage to produce the desired speed or position. For digital control, a PLC or other motion controller is used for generating the pulses in terms of duty cycles to produce more accurate control. The feedback signal sensor is normally a potentiometer that produces a voltage corresponding to the absolute angle of the motor shaft through the gear mechanism. Then, the feedback voltage value is applied at the input of error comparator amplifier. The amplifier compares the voltage generated from the current position of the motor, resulting from the potentiometer feedback, and to the desired position of the motor, producing an error either of a positive or negative voltage. This error voltage is applied to the armature of the motor. As the error increases, so does the output voltage applied to the motor armature. As long as error exists, the comparator amplifier amplifies the error voltage and correspondingly powers the armature. The motor rotates until the error becomes 0. If the error is negative, the armature voltage reverses, and hence the armature rotates in the opposite direction. The working principles of an AC servo motor are based on the construction with two distinct types of AC servo motors. They are synchronous and asynchronous, or induction. The synchronous AC servo motor consists of a stator and rotor. The stator consists of a cylindrical frame and stator core. The armature coil wound around the stator core, and the coil is connected to a lead wire through which current is provided to the motor. The rotor consists of a permanent magnet, and this differs with the asynchronous induction type rotor in that the current in the rotor is induced by electromagnetism, and therefore these types are called brushless servo motors. When the stator field is excited with voltage, the rotor follows the rotating magnetic field of the stator at the same speed, or synchronized with the excited field of the stator. And this is where the synchronous type is derived. With this permanent magnet rotor, no rotor current is required.
Thì cái database data ở bên ngoài thì đây nó sẽ sáng theo.
Stops, the rotor also stops. These motors have higher efficiency due to the absence of rotor
Như
current.
mình đã nói là indusoft
When the
webstudio là phần
position
mềm rất
rotor
hay
with
hỗ
respect
trợ
to
cho việc
stator is required, an
viết
encoder
SCADA
is
và
placed on
giám
the
sát thu
rotor
thập dữ liệu.
and provides feedback to the servo motor controller.
Chúng ta phải tạo
The
một cái
asynchronous or induction AC servo motor stator consists of stator core, armature winding, and lead wire, and the rotor consists of shaft and the rotor core winding. Most induction motors contain a rotational element, the rotor or squirrel cage. Only the stator winding is fed with an AC supply. Alternating flux field is produced around the stator winding with the AC supply. This alternating flux field revolves with synchronous speed.